Welcome to this session. In this session, we are going to discuss how to determine domain and range of relations, and also to find inverse of a relation. So the first thing, domain and range of relations. So I'll demonstrate this through examples. Find the domain and range of the following relations. So A, 2, 4, 6A, 9, 3, 5H, and -2, -6. If you remember, in the last session, we gave the definition of range and domain of a relation, whereby we said domain of a relation is a set of all first members in the pairs which form the relation. And then the range is a set of all second members of each pair in the relation. So domain of this is how we write domain of the relation A is given by the set of all the first members of the pairs. So we'll have 2, here we have 6, here we have 9, here we have 5, and here we have -2. So simple as that. That's the domain of this relation A. And range of the relation A, we have 4, we have A, we have 3, we have 8, and then we have -6. The set of all second members in each of the pairs. B, if I have the relation -1, 3, 4, 8, 1, 8, -3, 4, and then say 2, 2, and say -1, 9. So solution, domain of the relation B is denoted by D sub B. So pick all the first members in each pair. So we have -1, and then we have 4, and then we have 1, then we have -3, and then we have 2. This -1, those is because we are writing elements of a set, because we've already written -1, there's no need of repeating the element. And then range of B, we have 3, we have 8. Because we have already listed 8, there's no need of repeating it. And then we have 4, and then we have 2, and then we have 9. So that is how we determine range and domain of B. And lastly, if we have C, A1, B3, 6, 9, 7, A, and B6, then the domain of the relation C is set with A, B, 6, 7. Because we have already listed B, there's no need of repeating it. So that will be the set. And then range of C, we have 1, 3, 9, A, and then 6. So that will be the range of the relation C. So that is easily how we determine the range and domain of a relation. Number 2, find the inverse of the following relations and find their domain and range. So the thing is that we find the inverse. After getting the inverse relation, then we get the domain and range of that inverse relation. So the first one is A. Relation A is given by 2, 1. And then we have 3, 2. Then we have -3, 3. And then we have 0, 4. So this is our first relation. So the task is to find its inverse. And once we have the inverse of this relation, we get the domain and range. So this is 2, 1. So to get the domain, to get the inverse of a relation is a very easy exercise. What happens is that this all the second members become the first members of the pairs, and first members become the second members of the pairs. So for this case, the inverse of A, if written as this, will be given by, so this is 2, 1, so the element becomes 1, 2. This is 3, 2, so the element becomes 2, 3. This is -3, 3, so the element becomes 3, -3. This one is 0, 4, so the element becomes 4, 0. So that is the inverse. And so the domain of this inverse relation will be given by the set of all the first elements in each pair. So 1, 2, 3, and 4. And then range of that inverse relation will now be the set of all the second members of each pair. So the 2, 3, -3, 0. So that's how we find it. B, second relation is given by 1, 2, 2, 3, 3, 6, and 4, 8. So to get the inverse of this relation, you simply have the same number of elements and you interchange the order. First becomes second, second becomes first in all the pairs. So we'll have 1, 2 will be 2, 1. 3, 2 will be 2, 3 will be 3, 2. And then 3, 6 will be 6, 3. And 4, 8 will be 8, 4. So that is what that inverse will be, and which means the domain of this inverse relation B will be 2, 3, 6, 8. And range of this inverse relation is 1, 2, and then 3, and then 4. You pick set of all the second elements. And you see this one, 1, 2, 3, 4. Their first elements, all of them are different. So this actually defines a function. This relation is a function. And then here 2, 3, 6, 8, this also a function. These are relations that defines a function because all the first elements in each pair are distinct. And then C, I have the relation 2, 2, 3, 5, 4, 10, 0, 2, minus 1, 5. So this one, if you observe, see 2, 3, 4, 0, negative 1. So this relation itself is a function. Let's see whether the inverse will be still a function. So inverse will be 2, 2, 5, 3, 4, that was 10. So this is 10, so it will be 10, 4. And then 2, 0. And then we have 5 minus 1. So 2, 2, 5, 3, 10, 4, 2, 0, 5 minus 1. So the inverse relation, you see 2, 5, 10, 2, 5. So 5 and 5 are the same first elements, but different second elements. So this is not a function. Two, 2, and 2, 0 different. So this also can also be another reason as to why this inverse relation is not a function. So you can see there's a possibility of the relation being a function and this inverse not being a function. So the domain of this inverse relation will be 2, 5, 10. We have already listed 2 and we have already listed 5. So this will be the domain, and range of the inverse relation will be given by 2, 3, 4, 0, and negative 1. So that's how we solve that. And then lastly, we have a relation S given by minus 1, 5. And then we have 0, 2. Then we have 1, 1. Then we have 2, 2. Then we have 3, 5. So solution, let's see, this negative 1, 0, 1, 2, 3. So this is a function because all the first elements are distinct. So S is a function. Let's see whether the inverse will be a function. So S inverse will be 5 minus 1, 2, 0, and then 1, 1, 2, 2, and then 5, 3. So 5, negative 1, 2, 0, 1, 1, 2, 2, and 5, 3. So 5, 2, 1, 2, 5. So 5, 5, but minus 1, 3 are different numbers. Same first members, different second members in distinct pairs. So this is not a function. So this is also an example whereby the relation is a function, but its inverse is not a function. And then domain of S inverse. So it'll be 5, 2, 1. So once you have listed 2 and you have already listed 5, there's no need of repeating. And then range of S inverse. So -1, 0, 1, 2, and 3. So this is how we show that. Thank you.